Hi! In this video, I'm going to show you about the exact equation, where this is our last equation in first order linear differential equation. As usual, I always told you that we need to try to identify the type of equation. So in this exact equation, how to identify that we have exact equation? First, try to rearrange the equation in the form of you have m dx plus n dy equals to 0. Okay, so m is a function of x and y. Here you have a function of x and y, and then also you have n is a function of x and y, and then we equate to 0. Okay, note that always the general equation must be in the form of plus or positive sign. Alright, so now when you have m dx plus n dy equals to 0, so you can see that you have an exact equation. Okay, so I give you one definition here. We can say that if you have m dx plus n dy equals to 0, it is called an exact equation if and only if, okay, there exists a solution. Okay, mesti ada solution. You must have a solution where your solution is a continuous function. We call it as fxy. And this fxy equals to a constant. So any constant, you can name any constant. So let's say we call the constant as c. Okay, so you have a solution where the solution is a continuous function, fxy equals to a constant c, okay, such that del m del y equals to del n del x. So don't be confused. So here you have m dx plus n dy equals to 0. So that here you have del m del y del n del x. So the difference is here, okay? So since you have more than one independent variables here, so that your differentiation here will involve partial derivative. So partial derivative, the notation is like this, okay, not like this. So this is wrong. This is just normal differentiation where you differentiate a function with respect to only one variable. For example, df dy, okay? But when you have more than one independent variable, so in order to differentiate it, you must use this notation instead of the symbol of d. Okay, but still del or d here just to show that you want to differentiate function. Okay, so this is by definition. So what is the most important point that I want to show you here is the first thing is about this is your equation. This must be your equation, m dx plus n dy equals 0. And then in order to say that you have exact equation, you must show this one. We call this one is exactness test. Okay, so you must test for exactness. Uji ketepatan dia. Okay, so you have the exactness test. Then when you have or this exactness test is fulfilled or satisfied, so that the solution is exists, such that the solution is in the form of continuous function equals to a constant, any constant. Okay, so that is about exact equation. How you can say that you have an exact equation? You must test it. Yeah, you must always test it. Okay, so in the PDF notes, okay, it shows you about the method of solution. Okay, method of solution. There are how many steps? So we have 7 steps of solution, which is I hope that you can try to read and reread again and again the method of solution. But I'm not interested to show you about the method of solution. I just want to show you on how to solve it, so that you can try to map or match it with the method of solution discussed in this section. Okay, so let's continue. So now I have this kind of equation. Solve the following differential equation. If I rearrange this equation in the form of dy dx equals to, I put dy dx equals to something over there, I can say that I will never get homogeneous equation. Okay, because when you substitute lambda there, so that you cannot cancel out both numerator and denominator. Okay, so this is also not separable and this is also not linear equation. So let's try to go to the exact equation. So I try to match with the general equation. So I have okay, 2x plus 3, okay, dx, okay, plus 2y minus 2 dy equals to 0. So first of all, I rearrange this equation in the form of m dx plus n dy equals to 0. So in order to say that I have exact equation, what I need to do is I need to do the exactness test. Okay, uji ketepatan dia. Exactness test. Okay, so in order to say that I have exact equation, so what I do is del m, this one is m dx, right? So differentiate with respect to y, okay, the opposite variables, so that I have del y, my m here is 2x plus 3. Okay, so I want to differentiate partially 2x plus 3 with respect to y, so means that other than variable y, I must treat it as a constant. So differentiate constant obviously will give 0. Okay, what about del n del x? Okay, del n del x. So I put del x. Then my n here is 2y minus 2. Okay, so that when I try to do the partial derivative here, I want to differentiate 2y minus 2 with respect to x. The variable is x, okay, but when I try to differentiate this one, okay, I find that this one is y, so that differentiate y with respect to x here will give us 0. Okay, so I can conclude that del m del y equals to del n del x. Kenapa? Why this happen? Because both answer give us 0. So I can conclude that del m del y equals to del n del x. So that back to the definition, okay, back to the definition, the exactness test is fulfilled, so that we can have a solution, which is the solution is a continuous function here equals to a constant. This is our solution. So hold and bear in mind that this must be always our solution. This is the one that we want to find after this. Okay, so now then we go to the method of solution. Once we know that we have exact equation, okay, so now we want to solve it. Okay, I just copy the question first. 2x plus 3, okay, dx plus 2y minus 2 dy equals to 0. Since this equation is exact, so firstly we know that this one is m, this one is n. So now I note that the solution that we want to find after this is f x y equals to c. So this is the solution. So since f is the solution, so first step is you need to do is define your f. Okay, so I have here del f, okay, del f del x is your m. Okay, this is the first step. Okay, put del f del x equals to m, where your m is 2x plus 3. I equate this one as equation 1, and the other one is del f del y. So this one is n, and my n is 2y minus 2. This is my equation 2. Okay, this is the first step. The second step is, we know that this one is partial derivative partial derivative. Okay, so in order to get f from the differentiation here, what you can do is you can try to integrate. Okay, so which one you want to integrate, either this one or this one. So let's say I try to solve for equation 1. Okay, it's okay if you try to solve for equation 2. At the end of your solution, you can get the same solution. Okay, solve for equation 1 in order to get only f. So I just integrate del f del x. Okay, with respect to x, we try to integrate with respect to x. Okay, so now we try to integrate with respect to x here. So here we have, okay, differentiate something that you already integrate here. So what's left? Only a function f. Okay, and then integrate here, so that you have 2x squared over 2. 2x squared over 2, so that we have just x squared. Okay, plus integrate 3, so that you have 3x. And normally, we put a constant c after we integrate, right? But since you are dealing with partial derivative, so you cannot put just a constant. It must be an arbitrary function, where I call it as phi. Okay, phi what? Phi of a function y. Okay, when you integrate with respect to x, you must put the unknown function of y. When you integrate here, if you choose to solve for equation 2, so that you must integrate with respect to y, then after you integrate, don't forget to plus an unknown here, arbitrary function, phi in x, as a function of x instead of phi of y. So now, look at your right hand side of your equation. The right hand side of our equation consists of x and y. So that our f here, we can conclude that our f is as a function of x and y. Okay, actually class, we already reached our aim, where our solution is fxy equals to c is our solution. Here we go. Here, we have already the solution, but we need to find out. What is phi y. Okay, so now, in order to find phi y, what we need to do is we need to differentiate. Let's say I call this one as equation 3, okay? Differentiate equation 3 with respect to what? We must differentiate with respect to y. So that what I have here is differentiate both sides, okay? Differentiate your left hand side will give you del f. Since you differentiate with respect to y, so you have del f del y. While your right hand side is, when you differentiate x squared, you get 0. Differentiate 3x, also 0. And then when you differentiate phi y, obviously you will get phi prime y lah, the first derivative of y. So this is equation 4. So now, I want to know what is phi y. But at equation 4, okay, we have phi prime y. It must be a solution where we can eliminate the phi prime y in order to get phi y. Okay, so the next step is I try to compare equation 4 with the equation that I didn't use at the beginning of my calculation, which is equation 2. When you try to compare the left hand side, I have the same thing. Okay, so I can cancel out. Okay, and then for the right hand side here, I have phi prime y equals to this one. So that I can conclude that phi prime y equals to 2y minus 2. We don't want phi prime y. Why? We just want phi y. Okay, we don't want phi prime y, we just want phi y. In order to get phi y, what you need to do is you need to integrate both sides of the equation with respect to y. 2y integrate, so that you have 2y squared over 2, right? So we have y squared minus 2. So we have 2y, and then only we plus a constant. Let's say the constant is b here. Okay, why we can put constant instead of arbitrary function? This is because of we integrate with respect to only one variable here. Okay, and then you have here, okay, phi prime y, which is consists of only one independent variable here. So that now we already get phi y equals to y square minus 2 plus b. So now we actually get the value of, or sorry, this is not the value. We already get the function, the arbitrary function of phi y, and then we can substitute here. So when we substitute, we can see that we have the solution of phi x y equals to x square plus 3x plus y square minus 2y plus b. Okay, so this is our solution. Okay, not finished yet. Why? Because just now we say that, okay, by definition, the solution is a continuous function equals to a constant fxy equals to c, for example. So now we can say that, but, okay, the definition say that fxy equals to c. Okay, therefore I can say that, okay, c bring to this one, so I write the solution as c equals to x square plus 3x plus y square minus 2y plus b. So now we have two constants, b and c. Let's say I want to bring it to the left, so I have x square plus 3x plus y square minus 2y, okay, equals to c minus b equals to a, for example. So a equals to, I write it like this, a equals to c minus b. Okay, so I bring b to this one, so c minus b, so that I rename c minus b, I rename this one as a. So we have this kind of solution. So this is the general solution of what we call it as exact equation. If the initial condition is given, then only you put all the value of x and y into this solution, then you get the value of a.